All right, welcome everybody. Sorry we had some technical difficulties there. I'm Ethan, and it turns out you can do Node.js without MongoDB. Every tutorial I saw in Node.js when I was learning it at first, it was always Node.js and MongoDB. And so we're going to look at one particular library for dealing with relational databases. I really hope this isn't going to bore you all. How many of you are familiar with relational databases more or less already? Okay, most everybody. So for those of you who didn't have your hands up, there's going to be a whole lot of new and exciting material. For those of you who had your hands up, there's going to be slightly less new and exciting material. But how many of you have used knex before? Yeah, exactly. Okay, so that should be some new stuff. What we're going to go over tonight is what is knex, what problem does it solve, how to use it. It has a mechanism called migrations, and look at some caveats when testing with it. I am Ethan. I'm a consultant based out of Provo, and I spend most of my time helping companies with microservices and event-sourced architectures, and do that with training and implementation, consulting kind of stuff. And so when I'm doing that kind of stuff, this is kind of a layout of what those systems look like, but in the middle of it all is an event store, which stores all the events that get passed around to the things. And if we're going to build one of those, we need to put it somewhere. And I usually just do that with a relational database, and I think building one would be a really cool talk. But if we're going to do that, we need to know how to interact with a relational database in the first place. So that's kind of the birth of the idea for this talk. Anyway, what is knex? It's a query builder for various databases. And I didn't list them all, but it handles like MySQL and Postgres, MariaDB, Oracle. If you or your employer hates you, then you can do that as well. So what do we mean by a query builder? If you've written some SQL before, you'll recognize this as a SQL query. So one way you could interact with the database is to just send it raw query strings, right? That one's pretty simple, but this one is not so simple. I just yanked this off of Stack Overflow. I Googled complicated SQL query, and this came up. What I love about SQL, what was that?
I've built queries 3 times that size.
Yeah. What I love about SQL, though, is that it was invented so that people who weren't trained in programming could get data out of databases. And as these get more and more complicated, it seems like it takes the same level of training that programming would. But obviously it works. It's been around for a long time. It's tried and true. And
that's not even to mention the fact that if you just change the order of things, you can either reduce the amount of time taken for the query by half or vice versa.
Yeah, there is a lot of tuning.
Layers of complexity.
Absolutely, yeah. So I could do this. This is pretty simple, straightforward. It doesn't require any special tooling. If I send that string to a database that has a proper schema, it will give me some result. Yay, that's happy. But there are some caveats to that. One big one is the vulnerability of SQL injection. Have you all heard of SQL injection? Okay, so here's how it actually works. Here's an XKCD comic. Give you all a minute to read that there. Everyone done? Okay, so let's see what happens when we have this name for somebody. So here's that query again, and I have a placeholder. Oftentimes when I do a query, some of the things I'm checking against are going to come from my user. So if someone had actually named their child that string, and I just drop that straight into the query, here's what the query actually becomes. And so I have this here that completes a valid query, semicolon to end it. Then I start a new one called drop table students, semicolon, and that starts a comment so that the original closing tick there doesn't trigger any errors. So that's SQL injection. This should be on your list of things you don't want to have happen to your database. But anyway, so that's one big reason why I wouldn't want to deal with just raw strings. I could check for that manually, but why do that when there are libraries that do that for me? One other option for dealing with databases is far on the other end of the spectrum, and those are the ORMs of the world. In the Ruby world, Active Record. In the Node world, I think Sequelize is an ORM. And Frederick Bastiat, the celebrated 19th century SQL developer, He said that ORM is the great fiction through which everybody endeavors to pretend that rows in a database are objects in their application. I am very down on ORMs. I think they will mess up your application architecture in a very, very severe way. I preach a microservices thing, event-based and all that, and that's like categorically opposed to what ORMs will do. It's not to say that if you are not a super duper expert with an ORM, that you can't use it without messing things up. I'm just saying you've got to be like Kent Beck style of expert to know the differences there and not mess things up. So to me, that's kind of a spectrum, just sending raw query strings or trying to do an ORM. A query builder, somewhere in the middle, probably closer to the raw SQL side of things. It just gives some nice syntactic sugar without infecting your application's overall architecture. And so here's an example of, this would roughly translate to select star from users where the ID is equal to 3. And so instead of writing SQL, which I may not be terribly familiar with, I can write JavaScript, which I am familiar with. And that's one of the nice things that it does. So that's why you might want to use knex, but it does other things as well. So we just talked about that one. Another thing it does is a connection pool. So when you talk to a database, you have to establish a connection to it, and only one query can run at a time over a connection to the database. So in the Node world, that might not block us too bad because as additional requests are coming in, the way the event loop runs in Node, it'll kind of queue those up and run them when a connection becomes available, but still I'm limiting my throughput. So the connection pool essentially is when the app starts, by default, knex will do a minimum of 2 connections, a maximum of 10. So it can open several and handle more things concurrently. And you could do that same thing all on your own if you really wanted to, but again, why when a library handles it so well? Did I lose anyone on the importance of the connection pool? Okay, good. Next, it has a nice schema migration mechanism. So in a relational database, you have a schema that is enforced by the database itself. Who's used Mongo or other NoSQL tools before? Those also have a schema. They just live in your app code, not in the database. So your app needs to have some idea of what it's going to expect to find in the records in that database. But the database itself will pretty much accept anything in the Mongo world. In the relational database world, though, the database itself enforces the schema. So if I've got a table that has a column ID and a column name, and I try to insert something into a column tacos, it's going to complain saying, hey, I don't know about that column. Or if I try to insert a number into something that expects a string, it's not going to do that either. So migrations are a mechanism for evolving your database schema over time. And it provides a good way of doing that. So that's mostly it for the slides. Let's do some typing, which is always a treat. I am prone to typos, especially in front of people, but we'll see how this goes. Installing knex is pretty easy. Just whatever, if you use yarn or npm, just install it the way you would anything else. But remember, knex handles all sorts of different databases. It basically abstracts the specifics of Postgres or MySQL away from you. So you're going to pick a particular database to work with, and you'll also need to install the driver for that database. So it's not enough to just install knex. If I'm going to use Postgres, I also need the Postgres adapter in there. So don't forget that step, or else you'll get an interesting error like, hey, I can't find the database adapter. But it's really nice. The error message will say, why don't you try running npm install pg? So that's friendly. We're not going to actually watch this npm install happen because that would just be really boring. But let's see, is this even readable? Can we turn the lights?
I was just about to do that.
Thank you. And I can also make this bigger.
Is that better, or do you want them all the way down?
And let's take them all the way down. Yeah, keep going. Dark.
Does that work? Yay for backlit keyboards. Oh, that's not going up anymore. Oh, wrong one. There we go. Okay, so there are basically, actually might need to go back to the slides real quick. No, I don't have it. Okay. Wait, no, this is it. Okay, there are basically two different contexts in which knex will run. One is when you're running your migrations or seed files, which are a concept we'll talk about in a little bit. And the other is actually in your app. To run the migrations, you need to create what's called a knex file. And we do that by I've already installed knex here, so I'm just going to go to my node modules, bin folder, get the knex executable there. And if I just run it by itself, it'll print out the various options that it supports. But one thing I can do is just to run init. And all that's going to do is set up this knex file. And we can look at that real quick here. Notice the extension on that file is just JavaScript. So this is just a JavaScript file. There's nothing special about it except that it exports an object. And the one that it gives you by default has keys that match different environments, if you will. And I don't really like this way of doing database stuff like this, because having a file like this where you've hard-coded things like your database username and password, that's a really great vector to get that stuff checked into GitHub in a public repository. Well, for databases, maybe less, but I've heard stories. This is actually I've heard stories, I haven't done this myself, but where people have accidentally checked in, say, their AWS all-access credentials into GitHub. And in fact, for lack of a better term, let's say punks will scan GitHub for new repositories that have AWS credentials in them. And then essentially you get to pay a lot of money for other people to mine Bitcoin or run a botnet of some sort. And I don't know, I'm not into that. So I really don't like this way of structuring this. So also, if you are going to deploy to Heroku, this isn't a Heroku-friendly way of doing all that. So let us cheat here and go ahead and delete this one. And then through the magic of Git, we can go to step 1, where we have a different version of the knex file. So remember, it's just a JavaScript file. And now we're going to follow what Heroku wants us to do, which is their 12-factor thing. And one of them is that settings are supposed to come from your process's environment rather than being hard-coded into your system. So have we talked about, at some point in the past year or so, the .env library at a meetup here? OK, so .env is a really cool library. You might suspect it has something to do with environment variables from its name. What it lets you do is have a text file. This is not checked into Git here. But this text file, I can basically write some environment variable values in it. And what it does then is at runtime, it will read this and put into my process.env and allow wipe and a database URL. If you deploy to Heroku, they're going to supply you with a database URL that looks something like that. This is actually a legit Postgres connection string. And so armed with that, then, we can go back to my knex file. So all it's doing is it loads.env. This is just some shenanigans here to make sure I'm loading the right .env file, because I have development and test in there. But then all I need to do is export that particular string from my environment. So I've taken this big security risk and made it less of a security risk. People could still hack your machine and get access to your environment. But knex is able to work with just the string, and looking at it again, like you can tell from there, like, oh, this is supposed to use Postgres, and then this is in a well-known format where username, password, host, et cetera, et cetera. Now, I suppose you could have like what we saw before, where you split out the config into those objects with those different properties. You could parse this thing yourself, because since you're supplying it to yourself, you can make more assumptions about it being properly formatted. But I think it's a lot easier. Just get the database URL, export that, and knex is off to the races. Any questions about that? Did that lose anyone? Threads all connect? OK, cool. So that tells knex how to connect to the database. And then in step 2, step 2 is where we do this part. How would we actually use that in an app? When your app is running, it's not going to use the knex file. So let's look at a way to set that up. I'm going to call that the db.not-so-great.js file. And I'll tell you why I don't like this one. what are we doing here? We're grabbing knex, we're getting the database URL out of the environment, we're instantiating a client, and then we just export that client. What problems might there be with that? Any ideas? And then the idea is then I would then require this file at any place in my app that needed the database. Any takers on that? So what have I done? I've now coupled everywhere that needs the database to a specific implementation of the database. So I can't isolate things anymore. I can't pass a fake database if I want to. And now everywhere sort of has global access to the database. That sort of thing makes me uncomfortable. I solve that with a technique called dependency injection, which is probably a talk in its own right, but whoops, that's not the one I want. Better DB. So here, to me, is a better way to do that. First of all, one thing, I have this file called env.js. Its whole job is to extract all the environment variables that I care about. Why would I want to do that? Well, now I can come to this file and I can see every environment variable that the app cares about, rather than littering process.env all over my application. Because I know every one I need is going to be right here, I have this cool function require from env that if I don't find it, I can just give an error immediately when I try to start the app that says, hey, you forgot to set this thing. I don't have to do that, but I can. And I'd prefer to find out that I'm missing some critical configuration immediately rather than finding that out when things have been running and giving me weird errors. So this is just a file that gathers the environment variables I care about and exports them as an object that I can use in some other files right here, for example. So then the way I like to actually set the DB up is rather than create the client and export the client directly, I export a function that, given a database string, will return me an object that has a client. And that way I've decoupled this from where it gets its configuration. So for example, say I'm running a test and I don't want to set an environment variable because a set environment variable will affect all my tests. I can just pass it as a function parameter now. And that gives me some good benefits that are kind of beyond the scope of where we are today. But instead of just exporting the client, I export a function that creates the client. And then I can use that. I have an instance of it, and I can pass it to wherever it's needed. So that's kind of how to set it up. Any questions about that? No questions? OK, let's go on to the next step then, which is migrations. And there actually is a slide for this. So let's look at it. We mentioned these 2 points. There's a schema. It's enforced in the DB. MongoDB has a schema that lives in the app code. So here's an example table. If I try to insert things that aren't in there, I can't do that. But migration files are just simply JavaScript files that contain code that will change the structure of the database. And knex gives some nice tools for running them. They're meant to be run in order, and you can roll them back. And so let's look at some of them. Everyone close your eyes for just a few minutes while I delete some tables from this database that I should have deleted before getting up here. So, does anyone have some good hold music to play? That's a classic. Oh, can't drop that one. OK, so here's this fresh database that was totally set up this way before I got up here just now.
Ethan, do you have a question?
No. So this is a cool tool called pgadmin 3. There is a pgadmin 4, but I don't really like it because how many of you use Heroku? OK, so if you get a Heroku instance and you use Heroku PG, there's a really high probability that your database lives on a server with lots of other people's databases. And even when you connect to it using pgadmin 3 or 4, by default, you will see the name of all of those other databases in your list of ones here. You can't get access to them, but you see the names. But when your database is named something like ZVT36QP, like go find that in a list of 200 every time you want to look at your database. Not very much fun. PG3 provides a way to filter that so you can see just the one you have. PG4, at least as of when I decided I didn't like it, did not have that capability. Anyway, this is just a nice GUI for looking at your database. And we can see here there are no tables currently in my database. So let's do something about that. So again, get access to the knex executable there and migrate latest. So this is going to say run the migrations, run them all the way to the latest one. And I run that. And I have a migration in here called create events. Let's have a look at that file real quick. So I'm doing an event store. I'm going to need an events table. I'm going to delete all this real quick just so we don't get lost with those details quite yet. But a migration file essentially has two functions, an up and a down. And they're fairly self-explanatory. Basically, when I want to apply this migration to the current database setup, I do that in the up function. And then the down function should undo what I did in the up. Now, it isn't always possible to make that work. We'll talk about some cases where that wouldn't work. But in general, I want to try to undo what I do in the up. And so basically, it's a function that receives knex as a parameter. And then I can call knex schema create table, give it a table name. Then it gives me, in this callback that I have here, a table argument. And this is promise aware, so I want to return a promise. And so if I put back in here what I had before, this just is a little DSL for defining what my table should be. So table increments is going to set up a primary key column with an integer auto-incrementing thing. The primary key, if you're not familiar with SQL, is what uniquely identifies a row in a database, and every table really ought to have one. Then I have a bunch of string columns. These are useful metadata when dealing with events. I have a version that's an integer. My payload is a JSON object, and Postgres is JSON aware. That's a really nice feature of it. And then I want timestamps. So if I don't give it a time for when I created this row, it'll insert them into whatever the then current time is. And then I can also set up some indexes on here. So I set one up on type, and stream ID. And indexes just make it easier to query based on values in those columns, faster lookups, that kind of thing. Comes at a cost, though. Writes can take slightly longer. But that's basically it. So this blob here creates an events table. And then the down there, the opposite of creating a table is dropping it. So having run that migration, we can come back to pgadmin here, refresh. Oh, there are 3 tables, though. That's crazy, because I only created 1. So the knex migrations table, that is how knex remembers which ones it's already run. So we can look at the data in it. And so the first one in there is the name of the migration file. And so if I were to run the migration command again, already up to date. And it knows that because it checks that table against the names of the files in there. And migration lock, I'm not entirely sure what it's for, but I suspect it has something to do with locking the database when it's running or something. But here's a table we did just create with all the columns that we made. That's nice. Any questions at this point? Is that pretty straightforward or anything not clear? The reason why the knex file needs to be there is you'll notice in this file there's no reference to any of the app's other code. And so it needs to have the configuration information available in a known location. But we can do some more migrations if we... Oh, wait, let's look at this one. Sorry. Instead of migrate latest, if I do migrate rollback, it will roll back one migration from the current place. And so now if I refresh my tables, oh no, the events are gone. But that's OK, because I can just do them back. That's extremely useful when you're developing. Say you write the migration the first time, you're like, oh, I forgot a column. That's fine. Just roll it back, put the column back in there, and then rerun it. And yeah, so let's look at some additional migrations.
Question?
Yeah.
Can you do inserts, updates through this process as well?
You can. There's nothing in the code that will stop you from doing it. But I have a slide that's Ethan's rules for migrations, and I would advise against doing data migrations via this mechanism. The basic reason behind it is, suppose you had some table. Let's just get to the example right now. So hang on one sec. Let's skip to that real quick. Here we go. So number one on there is don't migrate data. So two-step answer to that question. One operation per migration. In that migration that we saw, I created one table. It had a number of things in it, but it was still a single operation. Even though knex runs these in transactions, I still like a migration file to only do one thing. So let's say I had a first and a last name column, and then how many of you have heard of a guy named Patrick McKenzie? Nobody? Okay, he writes really awesome stuff, and he had this one article about names in computer systems, and he had this list of, it was something like 100 rules, and for each one of them, there was some person on the planet that violated that rule. And one of the rules was even that the person has a name. So apparently there are people on the planet that don't have names. Anyway, so I grew up thinking everyone has a first name and a last name. That's not the case. So you started out your app with a first name and a last name. You realize, oh, that really doesn't capture everyone on the planet because obviously our apps go out to everyone on the planet. And I want to now just have a name column. And so what I'd like to do is create the name column, take my existing first and last name, concatenate them with a space, get that data into the new name column, and then remove the two columns that I had before. And so the reason why I wouldn't do the data part is, what if you have a million names and you've gotten through a bunch of them and then something breaks? It leaves it in kind of an odd state. And so the sequence that I would do is a migration to add the name column, some script that I've developed and tested outside of the migration flow that will actually do the data migration part of that, and then two separate migrations, one to remove the first name and then another to remove the last name column. So you can, I just don't, because I like to keep those concerns separated. But
thinking about cases where you want to see the table.
that is there is a seeds. That's what they're called. Knex provides a seeds capability. And so there's a directory you can have called seeds where you have JavaScript files in there. And that's their explicit purpose, is to, oh, I want to spin up a new developer with some default data. I can just define that right here. So it does provide a separate mechanism for that. Excellent question. Any others? Okay, let's go back to, whoops. This is what we want to do. Go back to here. So I have a couple of other migrations here. So this is like the world's premier video tutorial site. And so people are making those videos, and they're called authors. So here's a table to represent them very simply. And then here is a table to represent their videos. So knex allows me to specify the foreign key relation here. So foreign keys are like the thing that relational databases do. You have these separate tables, and they relate to one another, hence the relational database. By specifying this foreign key reference, I'm telling the database, hey, look, in this videos table, this column called author ID, that actually means the ID column of the authors table. Having now done this, if I can actually show this real quick in pgadmin. I'll need to run these migrations, of course. So let's run those. I come back here and refresh. I'm going to go to my videos table. I don't have any authors. So if I go to view these rows, and then I'm just using strings here for the IDs because in the kind of system I'd build, these would be GUIDs. So I'll just put some random text there. And I don't know, this is a cool video, and this is from author that. And now I go to save it, and it says in really tiny text, I can't do that. Why? Because you said there was some author with this ID, but when it looks at the authors table, it can't find an author with that ID. And so that preserves the integrity of your data. You can't insert a video without its corresponding author. You may think that's a feature, you may not, but that is the thing, one of the things that relational databases do that is sort of their reason for being. Any questions about that? That's usually some SQL syntax that you additionally have to learn. Sometimes it varies by a particular database, but knex, again, abstracts that for you. So it's just a table.foreign with the name of the table you're trying to set this on, what column it references on which table. And so that's kind of a nicer way to write it. It's more JavaScript friendly. So we just looked at migrations, so that brings us back to here. So these are Ethan's rules for migrations. We talked about the first two. Rolling back can't always restore your data to how it was. So in that name example, if we had a first name and a last name, and we concatenated their data into a name column and then deleted the first and last name, if we then re-added the first and last name columns, the data wouldn't mysteriously appear there. We'd have to do some other script to try to get it there. So migrations are destructive. Think of them as that. Treat them as if they are. So I know we are all seasoned professionals, and we're already running at least nightly backups on our project. But let's just say for giggles that we weren't. I would really recommend backing up your DB at some point recently before attempting to run a migration, because if you botch the migration, would you rather tell your boss, sorry, we're going to have to go down for an hour, or sorry, we lost the production database? Neither one's great, but one seems to be better than the other. And then this last one, don't edit migration files once they've been checked in. So they are part of source control. They are part of the state of the application, but remember that the knex migrations table is going to have a list of all the ones it's run. So if I have run these and I come back in here and I'm like, oh man, I totally forgot to put table foo in there, that will never actually make it into the database because this migration is not going to run again. Does that make sense? So the right way to do that is I would need to do another migration that would just simply add that table by itself. So the migrations, like events in a good event source system, are immutable. You don't change the migration files themselves. You add new ones. So if you added a table, let's say you added foo, and then later you realize, oh, that should have been called, or I didn't need that one. The correct remedy is to do a new migration that drops that column rather than just editing this file. Now, obviously, when you're still developing on it, you can change it. I will violate that rule if I am the only person working on it and I haven't yet deployed and migrated. But if you're on a team at all, never, ever, ever change migration files that already exist because the changes just won't get picked up. Yeah?
How is knex migrate knowing which migration to run based on those labels?
Based on these labels here?
The latest and rollback.
Good question. So migrate latest says to it, figure out where you currently are, and then just run until there are no more new ones. So what it's stored in the table there, let me close this down. And where'd it go? Here we go. So what it stores are the names of the files in the migrations folder. So here, 2017, 12, 12, 15, blah, 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 create events. So when we go back to the code, let me slide this over. It basically stores the names of these files. And these files are named with the timestamp of when they were created. So they sort well. So like this one will always come before this one in a sorting algorithm. So basically just goes down the knex migrations table, finds the last one, looks at what's in the directory, and then starts running in order the ones that it hasn't run yet. And so latest will just keep running until there are no more new ones to run. Or obviously if there's an error, it will fail at that point. And then rollback takes the last one in the table, goes and finds that file, runs its down, and then deletes it from the knex migrations table. So that table is entirely its memory. So if you mess with that table, you very severely mess with what knex can do for you.
Cowboy coders change the migration files and then just hack the database to make the change.
That's very true. I don't know if you heard that. We said the cowboy coders, they'll go ahead and edit the migration files that are earlier and then just log into the production database and go try to make it look like what the migration would have made it look like. I can't recommend that as a best practice, but it does happen. It absolutely does happen. Okay, so, yep. Oh, sorry.
You can roll back on top of rollbacks, right? So if you need to go back 3 steps,
That's right. I forget if it has a mechanism for it. Like I know in Rails, for example, you can rake db migrate and give it a target version, and it will roll back from the current until that version. At the worst case scenario, though, you just keep rerunning, press up, enter.
Yeah.
But yeah.
And there's no, there is a max. You run out of stuff to run.
Yep. Once that table's empty, it's like, I can't roll back anymore because there is an empty database sitting here. But yeah, exactly. So it's a nice way to share the schema. Prior to migrations, I wasn't actually a developer before this concept was invented. It was kind of like, hope the database is in the right state. Those of you who worked with them back in the days, was there a dedicated DBA team that would get the schema right, and then you'd have to talk to each other? And anyone know how this was handled back?
I generally ignored the problem.
Did you? Okay. All right.
Yeah, just I never had that problem because it was somebody else's problem.
Gotcha.
And database administrators hated me for that. So.
I don't envy their job. But the other nice thing it gives you is now the database schema is reproducible for any developer who comes to the project. If you're doing a knex project, new developer comes on, they pull the code down, they manage to get a database set up and connect to it, they just run knex migrate latest, boom, they have the current schema. And there's no craziness involved with that. And that's a nice feature. Any other questions on the migrations or why they're valuable? Okay, let's move on to testing with knex. There's nothing really strange about it. I mean, when you test code, you run it and see if you got the results that you expected. But there is one oddity if you use the tape library. Who uses tape for testing? Yeah, that's great. Yay, tape. Here's that oddity. Let's go to it. Okay, so this all loads up. Let me close some files here. Don't save. I have this awesome something test file, and I actually need to break it real quick so that we can see the problem. Let's see. Okay, so a node process, when you invoke it, runs until there are no more events in the event loop, and there's nothing else that could produce events. So when I open a knex connection, though, I've now opened a persistent thing that could cause new events. So if I run, just npm test here, assuming I broke, oh, that was not supposed to happen. That's such a shame. Let me see what the problem is here. You have to save files for them to take effect. How quaint. Yeah, it's weird, right? It must be an old computer. Maybe the new MacBook Pros don't work that way. But so I have a test here that can has test please, and it doesn't do anything except it tells us the truth. I will hang. I opened a knex connection. My test ran, but nothing told knex, hey, shut down. So it just hangs the process. And if I'm in a CI environment, my test all ran successfully here, but it's going to observe a timeout and then say, well, test all failed. I don't know, that's not brilliant, and it only happens with tape because a test runner like Mocha knows to kill the process once all the tests have completed. So a really easy way to fix that, let's pretend for a minute that this config object contained a reference to that database thing we created earlier, and that database thing has a client, and that client has a destroy method. This basically just informs tape, hey, when you're all done, when there are no more tests to run, call this function. And in that function, I'm just saying, okay, knex, shut yourself down. So if we uncomment that code, and then, of course, save it, because you have to do that with these modern computers, and then run the tests, now they will actually complete. So the first time that I encountered this, I was not happy, because it made no sense. Why are these tests hanging? Nothing went wrong. And much Googling and Stack Overflow found the answer. So if you ever use knex, just know that little tidbit. You have to tell it to shut itself down, or else it's not going to.
That's just the current connection.
That's right, yeah. If your test happens to not open the database connection, then you won't run into the problem. But the way I currently have it set up, it will establish a connection, and I just need to tell it to shut itself off. The other thing is that if you have a database in your test and you write stuff to it, and you're going to end up with stale data in there that could affect your other tests, so you need to clean up after yourself. The sort of pattern I've come up with for doing that is the following. So here is that same file where I created the database. I've given it some extra parameters now. One is an allow white flag. This will be a Boolean. I supply that through the environment. And then I have this tables here. And I have this function called wipe that will essentially do a sort of it's a reduce but with promises to loop over all the tables that I specified and drop them. And I only want that sometimes. Like, that's not a feature I would like in my database in production. So in my test file here, I will set allow wipe to true. And then, whoops, sorry, wrong key. And then in my env.js, when I'm setting that up, I'll make sure that I've specified one or the other, and then I'll set it to whether or not it equals true. So that's how I control whether or not I add that in. And so we can go back, whoops. Well, actually, we already looked at that. So looking at the something test then, now that my database has this wipe function available, I just start the test by wiping the database, which will just drop all the content and all the tables. But because I have my primary keys there, I keep hitting not the command key. Sorry, okay. Because I have that primary key constraint, I have to drop the videos before the authors, because let's see what happens if we don't do that. Cut that, and then put this over here. And now let's run our test. Why did that? Oh, wait, no. Why did that work? Oh, never mind, sorry. Hopefully this will fix it. This is why I hate live coding, incidentally. Make sure that is up to date. I saw this error earlier because I tried to actually make it happen. Huh. I am really confused by that. All right, I'm sorry. I'm not going to be able to demonstrate it, but what it's supposed to do is, maybe I have, no, that's what it was. Okay, sorry. There's no data in there, so it can go ahead and drop it. I just went and manually did this. That is not the test database. This is the test database. I come in here, and what I want to simulate here is having run, which one? Sorry, this is exciting watching this, I'm sure. If I wanted to come in here and do, say I had some author, and then I had some video, and it had a name, and it referenced that author. Like, this is all legitimate stuff here. I really hope this errors out because it's supposed to. There we go. Yay. And so what we see here is if I try to drop the authors first, I violate the foreign key constraint because I have a video that depends on the author, but now I'm trying to remove the author and the database says, nope, you can't do that. And so when you're clearing a database like that, you have to take into account the order of those dependencies. So if I change this back and then clear this and run it, now it runs just fine. Did I see a hand go up there just a minute ago? No. Okay, so those are the caveats in testing. Know that it won't auto shut down the connection and that you also have to clear the database between tests so that they don't mess each other up. And can run this again. Knex has support for transactions. If you're not familiar with SQL transactions, this is their other big thing. Basically, it's like if I have a series of queries, if I run them in a transaction, they're either all going to work or none of them will work. Imagine if you had a banking application here. If I wanted to transfer money from here to here, it's going to be 2 queries. This is a horrible way to do a banking application, by the way. And I think event sourcing is much better for something like this. But let's pretend we were doing this the not good way. But we wanted to do it only 95% horribly instead of 100% horribly. We would wrap this in a transaction because first I need to reduce the balance here, and then I need another query to increase the balance here. What happens if it fails after that one and I'm not in a transaction? $100 have just disappeared from the system because they were removed here and never updated here. So Knex has support for that. It looks a little bit like this. There's a knex.transaction function. You give it a callback. It gives you an object. That's essentially a client like the other one we saw before. It's just now it's all running inside of a transaction. If you have an error, it will roll it back and undo everything you had done. If it succeeds, it will commit it. And then, so in this example, when this transaction action succeeds, those two queries are both committed to the database. It gives some nice support for when your queries need to check certain values. So like if I wanted to find all the videos that had a view count greater than 5, there is supposed to be a comma there. And watch this. Now there is. And so that would give me all the videos that have a view count greater than 5. Sometimes, though, in our videos table, we had a link to the author, but what if we wanted to see the author's name and we don't want to issue a query for the author of every video? That's where the concept of joins come in. So I can grab here from the read model videos, find me all the ones that have a view count greater than 5. Then what's called a join, I can essentially take the two tables, smash them together where they match up on the author ID, and that's what we're saying here. So join this table to the read model authors table where my video's author ID is equal to the author's ID. So now the rows that come back from this query are going to have the data from both tables, and I'm able to get the author's name without having to like find 10 videos that match this and then 10 more queries to get their author. Yeah.
What's the significance of the capital R in the read model at the last read model?
The significance is that the slide software capitalizes the first letter of the word and I missed it. So, what capital R? Thank you for pointing that out. Yeah.
It's case insensitive.
I think SQL is, and that's why even in Node.js you end up with underscores in here, which is a really excellent point. The rows that come back are going to be plain old objects, and they're going to be named exactly like how the column names are. So that feels weird to me, and at times I've written transform functions that will take all the underscores and camel case them, but I'm just like, yeah, what's the value in that? So yeah, otherwise they'd all be run together. What was that, Aaron?
Is it getting more processing?
Yeah, I don't know. I learned to surrender that bit of OCD-ness and move on. Anyway,
I would have done the same thing.
everyone starts there, right? Anyway, so knex is a query builder library. It removes some of the horribleness. If you like sending raw SQL queries to the database, more power to you. I don't. Knex gives me a nicer syntax to it, but it doesn't go the ORM route where I pretend that rows in a database are actual full-fledged objects. That can lead you to some problems. Usually I'm not shutting up about microservices, so if you're interested in that, you can read about it. And I'll post the slides in the meetup. And any last questions? Yeah.
Can you roll back one slide?
Yes, I can.
Do that query that you sent with join.
Mm-hmm.
Are you saying that the column names are going to come back in that format? Table.column, table.column?
Dang, that is a good question.
Or can you provide column aliases anywhere?
You can do that. Knex provides the capability for doing that. I could have done a select in here. Like there's a select function where I can do all the same column as something else. But I think, yes, in this example, I think it would have to give the table names in case there were collisions of any sort. I'm not sure. I'm sorry, I don't have a better answer. But do be aware of that if you start doing joins with Knex. Watch for that. Any other last questions? Okay, cool. Well, thanks, and happy coding.
It supports all standard query groupings, like the have clause.
Mm-hmm. It has functions for those, yeah. And as a last resort, there is a knex.raw function where you can pass it the raw stuff because, automated query generation, it's not going to be tuned necessarily.
Can it support push state databasing? If you change something in the database, can it push an event onto an event bus?
That I don't know. That's a good question, too.